So we've been looking at the if conditional and the if else and the if else conditional, but Java and many other programming languages have another conditional that you may find useful. It's called the switch conditional, and it looks something like this, where you use the word switch, then you have a condition. I'm going to explain what that means in a minute, and then the body of the conditional. And what goes in here, and I'm going to make a copy so that we have a code description of it, is really more of a variable than a condition. Then you have what are called cases, and you have default. So a good example of this, let's just kind of keep it simple, is let's say that we're going with letter grade. So I'm going to do a character, we'll call it a letter grade, and let's say the letter is A, and I'm going to switch on the letter grade. So we'll have a few cases. We'll have case A, case B, case C, case D, case F, and then we'll have the default. Okay. And inside the first case, we'll just say system.out.println, and we'll say this means you got at least 90%. And then we'll do the same for all the other letters, and we'll make the adjustment. This is 90, so this is 80, 70, 60, 0, and then for default I'll just say invalid. And we'll talk about what these mean. So I'm going to get that, clean that up. I'm going to run my auto formatter. There we go, it's cleaned up a little bit. Oops, too much formatting. So we'll do format, just the selection. There we go, perfect. Save that. So what the switch does is, okay, here is the thing I want to switch on. In this case, I want to switch on letter grade. So we're not switching on a boolean value, we're switching on a character or an integer or even a string value. And we're saying, okay, which case matches the thing I'm trying to match? So in this case, I'm using the letter A for my value, so this is the case that matches. And so just like with an if, we have the system here, but the nice thing is it's a little more optimized with the if, else if, else if, else if. I wanted to do this with the else if, right? I would need about 5 or 6 cases here, 5 or 6 else ifs, and all 5 of those may need to be checked. The switch statement gets optimized under the hood so that it's not running all of those checks, it's only checking the one that matches. So it's pretty quick and effective compared. But if I run this, you're going to see there's a problem with it. It printed all of them. And it even printed this default down here. That's because when you finish a case, you have to put a line at the end that says break. And that says, okay, I am done with this case. You technically wouldn't have to do it for the default, but it's kind of free to do, so it's better for consistency. Now if I run Java, I only get the A case. So the break says, okay, I finished the code in this case, I don't keep going to the next one. The break says you finish that case, you can leave the switch. Now, even if I change this to D, run Java, you got at least 60%. So that's one way to use the switch statement. Another way we can use it, and we're going to build on this a little bit, is let's say that I have my grade. And let's say that my grade is a 96. If I only wanted to know the tens digit, or the hundreds and the tens, right? I could say, okay, what is my grade divided by 10? And the reason I'm doing that is because if my grade is a 90, or a 91, or a 92, all the way up to a 99, this will give me a 9. If my grade is an 84, or any 80 number, it'll give me 8. If it's any 70, it'll give me a 7, and so on and so forth. So what I can do here is I can say, okay, instead of the letter grade, I'm just going to switch on the check grade. So if my grade divided by 10 is a 6, I know that that means I got a D, because that means that my grade was in the 60s. If it is a 7, I know that I got a C because it was in the 70s. If it was an 8, I know that it was a B because it was in the 80s. If it was a 9, I can say that I got an A because it was in the 90s. And if it is 10, I can still say that I got an A because that means it was 100. So take your grade, divide it by 10, and remember, because it's an integer, it's not going to have a decimal. So it's just going to be a 6, 7, 8, 9, 10, or if it's anything else, anything that's below that. So if a 50 or a 40 or a 30, 10, 0, all the way down to 0 means you got an F. So now if I run this code with a 96, I should have gotten an A. If I run it with 100, I still get an A. If I run it with a 56, this is probably going to give me an F. And it does. And then if I run this with, let's say, a 73, it will also give me a C. And this is a good example to look at because, remember these breaks? It seems kind of weird that you should have to put these in here. Why doesn't Java just automatically know, oh, you're done with it, you're done with your case, you can move on to the next one? That's because you have something called fallthrough, where you can actually move from one case to the next. So really, case 9 and 10, if you look, these are exactly the same. If it's a 9 or a 10, I still got an A. So what I can do is I can delete these 2 lines of code here, and there's a fall through here. Case 9 doesn't do anything, it just falls through to the next case. Now if I run this code again, let me run with just the 100. Got an A. And I'm going to try it again with, let's see what happens when it's a 90. Okay, it worked. So if we look here, here's what's happening. Switch on check grade. Okay, grade was 90, so check grade is 9. So switch on a 9, and that takes me here. And notice there's no code in this case, but there's also no break, which means run the code in the case, which in this case is nothing, and then keep going. Because when you hit a case, or even when you hit the default, you keep going until you hit the word break. So case 9 doesn't do anything, but there's no break, so we fall through, we keep going. Case 10, print, you got an A, break. Even if I have something like 89 here. If I run this, I print you got a B because, okay, you got a B, but then there's a break. So even though there's no code in case 9, we can still get to the code in case 10 because there's not a break. And even though there's not a break in case 9, the other cases above it aren't impacted because they do end in break. And so that's why break isn't a kind of a default behavior. You have to specify it explicitly because you can get this extra behavior with nothing else. Even if you wanted to, you could actually put some code in here, and we could say system.out.println. I can say it wasn't a 100. Okay, I'll change this back up here. We'll say this is a 93. Run it. So I can say it wasn't 100, but I got an A. So I did put some code in case 9, and it still went on to case 10 because of the break not being in case 9. So this is another conditional structure that Java has. A lot of other languages have it. Python does not have this, but you can kind of trick it into thinking it does, but you don't get fall through. So the fall through is an extra thing you can do with switch statements. Some developers are not a fan of fall through, some are. It is definitely something that when you really need it, it's nice to have, but it could also be something that you don't actually need. It's something that you could maybe find better workarounds for. Like here, maybe it was just a coincidence that 9 and 10 were the same case and we could have just duplicated this code, but it also prevents having to duplicate code. So the switch statement is another good conditional to play with. Another thing to keep in mind with it, just a few things. Remember, you're not checking a boolean, you're checking an int or a char or a string. You're checking for what cases does it match. Every case needs to end with a break unless you want fall through. So 6, 7, and 8 have breaks in them, so does 10 because we don't want them to fall through. Case 9 does not have a break because we specifically wanted this one to fall through since 9 and 10 have the same behavior. And then every switch you write should have a default case to catch anything that maybe you weren't planning for. But this is a good conditional to play with, and it opens up a few more doors that you weren't given by the if, else block. And it is a little bit cleaner than using a bunch of else ifs. In fact, a lot of code cleanup tools, usually called linters, if you are using if, else's, and you're using a lot of else ifs, they will recommend that you change your code or you refactor your code to use a switch statement instead, because it does the same job, but it's usually a better practice to use the switch statement if you're going to have a lot of conditions. But that's the switch statement, and in the next video we're going to look at another construct in Java that you can use with the switch statement that's kind of a nice little feature to use.